Good morning, children. Let's continue discussing exercise 10b. So in the last class we have discussed question number 2. So let's move to question number 3. So we'll be doing question number 3, Roman number 2. If u is inversely proportional to v and if u equals 12 when v equals 3, find u when v equals 9. So it is given that u is inversely proportional to v and the value of u is 12 when v equals 3. Similarly, we need to find the value of u when v equals 9. So it is given that u is inversely proportional to v, so therefore we have written u is inversely proportional to 1 by v. So that means u into v is equals to k, so which is a constant, where k is a constant. So if u equals 12 and v equals 3, then uv, so it is already given in the question when u is equals to 12 and v is equals to 3, then u into v, that means 12 into 3 is equals to 36. So this is the value of k. So therefore k is equals to 36. So once we got the value of k is equals to 36, so therefore it is given that when the value of v is equals to 9, we are asked to find the value of u. So therefore if v is equals to 9, then u into v is equals to 36, that is u into 9 is equals to 36. That means this is the value of k. Since it is a constant, since it is inversely proportional, therefore u into v is constant, so the value of constant is 36. So therefore u is equals to, this 9 comes down, so it becomes 36 by 9, that is the value of u is equals to 4. So similarly you can do the rest, all are similar to this, that is Roman number 2. So let's move to question number 4. Naveen cycles to his school at an average speed of 12 km per hour. It takes him 20 minutes to reach the school. So that means when Naveen cycles at the speed of 12 km per hour, it takes 20 minutes to reach the school. If he wants to reach the school in 15 minutes, suppose he want to reach school earlier, that is in 15 minutes, so what would be his average speed? So we need to find the average speed so that he can reach school within 15 minutes. So given if the average speed is 12 km per hour, then the time taken to reach the school is 20 minutes. So this is already given. So let the average speed be x km per hour if time taken to reach the school in 15 minutes. That means the speed that he must move in order to reach school in 15 minutes we take as x km per hour. So then we have the following table, that means we represent the above situation in this following table. So this is the speed and this is time. So when the speed is 12 km per hour, the time is 20 minutes, and when the speed is x km per hour, the time is 15 minutes. Now since we know that they are inversely proportional, obviously if we increase the speed, the time taken will be less. So if we increase the speed, the time will be less. So that means when the speed increases, the time decreases. So therefore they are inversely proportional. So therefore we have written that the average speed is inversely proportional to 1 by time. And since they are inversely proportional, we already know if x is inversely proportional to y, that means xy is a constant. So therefore this will be a constant. So that is 12 into 20 is equals to k, where k is a constant. 12 into 20 is equals to k, that means the value of k is 240. So therefore x into 15 is equals to 240, since this is the value of k, so value of k remains same. So therefore x into 15 is equals to 240, which is the value of k. So the 15 comes down, if we send 15 to the other side, it becomes divide. So 240 divided by 15, so that is 16. So hence the average speed will be 16 km per hour. Again, let's move to question number 6. 28 pumps can empty a reservoir in 18 hours. In how many hours can 42 such pumps do the same work? 28 pumps can empty a reservoir in 18 hours. So in how many hours can 42 pumps do the same work? So given 28 pumps can empty a reservoir in 18 hours, this is already given. So let the time taken by 42 pumps to empty the reservoir be x hours. So then we represent this situation in the following table. Then we have the following table, that is number of pumps we have written here and the time we have written here. So when the number of pumps is 28, so the time taken is 18 hours. So when the number of pumps is 42, so the time taken we have taken as x, so we have written here x. Now if the number of pumps is increased, obviously the time will decrease. So if the number of pumps is increased, obviously the time will decrease. So therefore that means what? They are inversely proportional. So therefore we have written that the number of pumps is inversely proportional to the time. So that means what? 28 into 18, so it is the value of the constant, that is k, where k is a constant, therefore k is equals to 504. So therefore x into 42, now if we multiply these two also, we will get the same value, that is k, since k is constant. So therefore x into 42 is equals to 504, which is the value of k. So therefore x is equals to 504 whole divided by 42, that is 12. So hence the total time taken is 12 hours. So then let's move to question number 8. Question number 8 is given: a contractor who had a workforce of 630 persons undertook to complete a portion of a stadium in 14 months. He was asked to complete the job in 9 months. How many extra persons had he to employ? So a contractor who can finish the work of a stadium, that means he's building a stadium, so he can finish that stadium in 14 months, and the number of persons that he will employ there is 630. Now he is asked to finish the work within 9 months. So obviously if he need to finish the work early, that means within 9 months, so he will be needing more, that is manpower, that means more worker will be needed. So it is in the question that how many extra persons he had to employ. So apart from 630, how many extra person he need to complete this job earlier, that is within 9 months. So it is already given in the question that given number of persons needed to complete the work in 14 months is 630, which is already given. So let the number of persons needed to complete the work in 9 months be x. So we consider the number of persons needed to complete the work in 9 months be x. So now let us represent this situation in the table. So then we have the following table, that is months we represent here and the number of persons. So months, when the number of months is 14, so number of persons is 630, and when the number of months is 9, we take the number of persons as x. Now these months and number of persons are inversely proportional. Obviously when the number of workers will be more, the time taken will be less. So therefore month and the number of persons are inversely proportional. So therefore 14 into 630 as similarly as earlier. So 14 into 630 is k, that means it is a value of the constant, the value remains constant here. So therefore 16 into 630 is k, where k is a constant. So therefore 9 into x will also be equal to the value of k. So since k is constant, so therefore 9 into x is also 14 into 630, which is the value of k. So if we find the value of x, that means if we send 9 to the other side, it becomes divide. So we cancel this 630 with the 9, so 9 1 is 9, so 9 70 is a 630. That means 14 into 70 is 980. So the number of workers needed to complete the work within 9 months is 980. But in the question it is asked, we need to find only the extra persons that he had to employ. That means apart from 630, how many persons extra he will employ to finish the work. So here the total person needed is 980. Therefore the extra person needed is, so earlier there is 630 persons are already there. So the total is 980, that means 350 will be extra. So these 350 persons he needed to employ extra in order to finish the work within 9 months. Let's move to question number 11. A garrison of 800 men had provision for 39 days. That means 800 men can eat for 39 days. However, a reinforcement of 500 men arrived. That means 500 men came extra from outside. For how many days will the food last long? Now, obviously since the number of men are more, so obviously the food will not last longer. So number of days will reduce. Since the number of persons has increased, so the number of persons to consume this food have increased, so therefore the number of days that the food will last will obviously decrease. So it is given in a question that garrison of 800 men had a provision for 39 days. That means 800 men can eat for 39 days. So new reinforcement. So how many persons came extra? 500 persons came from outside extra. So therefore now the total men. So what are the total men now? Earlier there are 800 men. Now 500 men came extra from outside. So therefore the total is 1300, that is 800 plus 500, that is 1300. So let the provision for 1300 men be X days. So we take this provision, that means the food that the food will last for 1300 men be X days. So then we have the following table, that means we represent this situation in the table, in this table, that a number of men and days. When the number of men is 800, that the food will last for 39 days. When the number of men is 1300, the food will last for X days. So obviously, therefore the number of men is inversely proportional to the number of days. So obviously when the number of men is more, the number of days will be less. So therefore 800 into 39, so the first entry, that is 800 into 39 is constant, is the value of a constant, that is k. So therefore 800 into 39 is equals to k, where k is a constant. So therefore x into 1300, so this x into 1300 will also be the value of k, that is constant. Therefore x into 1300 is equals to 800 into 39, that is the value of k. So if 1300 moves to this side, it becomes 800 into 39 whole divided by 1300. So 0 0 cancel, and this 13 we can cancel, 13 1 the 13 and 13 3 the 39. Therefore 3 8 the 24. That means hence the number of days is 24. That means the food will last for 24 days. So that's all for today. The remaining we will discuss in the next class. Thank you.